All right, in chapter 2, we're going to be talking about operations with integers. So we're going to be working with these types of numbers called integers. So our first lesson here in chapter 2 is integers and absolute value. So we're going to talk about some basic types of numbers today and a little bit about absolute value if you've never heard of that. So we're going to talk about some of this vocabulary here. We've got positive numbers, and positive numbers are any numbers greater than 0. Negative numbers, those are any numbers that are less than 0. And an integer is any positive or negative whole number. So integers are always whole numbers. They have no decimal parts or no fraction parts, but they can be positive or negative. We also have opposites, and these are numbers that are the same distance from 0 on the number line. So 1 and -1 are opposites, 2 and -2 are opposites, 10 and -10, and so on. Those are opposites. And then, of course, coordinate, we use that in chapter 1, but that's the number that corresponds to the point on a number line. And then inequalities, that's when we use a comparison or make a comparison in math, and it's a math sentence that contains either the less than or greater than symbol. So just graphically here on the number line, take a look at what I just talked about. So we've got 0 in the center of our number line here. And of course, positive numbers are all the numbers that are to the right of 0. Anything to the right of 0 is positive, and then anything to the left of 0 is negative. And 0 is neither positive nor negative. And then when we talk about graphing or finding the coordinates of numbers on the number line, this number line on the right illustrates that. So we've got -5 graphed on the number line, and we've got +4 graphed on the number line. Here a little bit more detail about what an integer is. So I've got some examples and non-examples of integers. So in the left-hand box here, we've got integers or examples of integers. So again, integers can be positive or negative whole numbers. So 6, -945, 147, 2, 0, those are all integers. And in the right-hand box, I've got some examples of numbers that are non-integers or non-positive or negative whole numbers. So anything that is a decimal, anything that is a fraction, either positive or negative, mixed numbers, repeating decimals, all of those things are not integers. And then down here, I've got a Venn diagram that kind of illustrates the expansion of our number system. Most of the time throughout elementary school, you deal with whole numbers, and that's this group right here. Whole numbers start with 0 and then count up 0, 1, 2, 3, 4, 5, so on and so forth, as far as you can count. And then we introduce negative numbers. So we've got the whole numbers and their opposites together is this large group called integers. So when we talk about integers, we're talking about either positive whole numbers or negative whole numbers, and that includes 0. 0 is an integer. So for each situation here, let's come up with an integer that represents its value and then identify its opposite and describe what it means. So 23 degrees Fahrenheit below 0, if we were to pick an integer, something on the number line, a positive or a negative whole number, to represent this value, since we are below 0, that's indicating that we're a negative value. So -23 would be the integer that I would use to describe 23 degrees below 0. Now we have to identify its opposite. The opposite of -23 would be +23. And then we have to describe what that +23 would represent in this situation. Well, +23 would be 23 degrees Fahrenheit above 0. And then a loss of 8 yards. So we're talking about maybe football game here. So a loss of 8 yards, an integer to represent that value would be -8, and its opposite would be +8. And a +8 in football would represent not a loss, but a gain of 8 yards. And then lastly here, we've got some a financial statement here. A deposit of $15. A deposit, now that means that you put money into your bank account. So a deposit would be a positive value, so +15. and then its opposite would be negative 15. And what would that mean if we were talking about our bank account? If we had a negative 15 on our account, that would mean that we withdrew or took out $15. So that would be a withdrawal of $15. So integers and their opposites, identifying integers for given situations. And then here we want to make some comparisons between integers. So we're going to write inequalities. There's actually two inequalities you can write for any comparison that you're going to make between two numbers. So we want to write two inequalities comparing -6 and +1. Well, -6 is right here on the number line, and +1 is right here on the number line. So 1 is further to the right on the number line, so that means 1 is greater than -6. So we could write that inequality, 1 is greater than -6, or we can actually turn that statement around and say the same thing, but say -6 is less than 1. -6 is less than 1. So less than is the arrow pointing to the left, greater than is the arrow pointing to the right. So those are two inequalities we could write that compares -6 and +1. And then the next one, write two inequalities comparing -4 and -2. Well, -4 is right here on the number line, and -2 is right here on the number line. So -4 is further to the left. So -4 is less than -2. Or we could turn that statement around and say -2 is actually greater than -4. So ways to compare integers using our inequality symbols. Next concept we want to talk about is this concept of absolute value. Now, absolute value is the distance a number is from 0 on the number line. So absolute value always describes a distance. And when we talk about distance, we don't use negative values. So if you could imagine if somebody, or if you ask somebody, hey, how far from school do you live? And somebody said, oh, I live -3 miles away from school. People don't talk that way. When we talk about distance, we talk about positive values. So the absolute value of a number is the distance the number is from 0 on the number line. And the absolute value of a number is always greater than or equal to 0. It's, in other words, it's always positive. And then how do we write that in math? The notation. You'll see these little bars here around the number, and those are called the absolute value bars, and you would read that the absolute value of -6 is 6, because -6 is 6 units from 0. So we can see that right here. -6 is 6 units from 0. Also, +6 is 6 units from 0. They're the same distance from 0, so their absolute values are the same. So -6 and +6 have the same absolute value. They are the same distance from 0 because they're opposites. They are the same distance from 0 on the number line. So when we see those absolute value bars, we're always talking about distance, and that's always going to be positive. So let's evaluate or find the value of these expressions here. So this first one, I have the absolute value bars with a -4 inside, and that's asking what is the absolute value of -4. In other words, it's asking how far is -4 from 0. So I included a number line here. You can see here's 0, here's -4, and it is 4 units away from 0. So the absolute value of -4 is 4. It is 4 units from 0. Here we have another expression that contains two absolute values and an operation in between them. So we're going to treat the absolute value bars like grouping symbols. Remember when we did the order of operations? It's like parentheses, so we have to do the absolute values first. So the absolute value of -8 is 8 minus the absolute value of 5. Well, the absolute value of 5 is 5. It's 5 units from 0. Don't get it confused with opposites and say that the absolute value of 5 is -5. That is not absolute value. That's opposites. So please try to keep those two concepts straight in your mind. So we've got 8 minus 5, which is 3. And then the next one, we have to again find the absolute values of each of these terms. So the absolute value of -4, we saw that up top, is 4, minus the absolute value of -3. Well, -3 is 3 units from 0. So really this is 4 minus 3, which is just 1. So again, really absolute value is quite simple. You just have to find the positive value or its absolute value. Here we have some algebraic expressions that contain the absolute value bars. Again, we're going to evaluate just like we did before. In chapter 1, we're going to use the substitution property of equality here and substitute. I know that y is -7, so this is the absolute value of -7 plus 8. And the absolute value of -7 is 7 plus 8, which is 15. And then a note here, when you're writing your absolute value bars, please make sure you make the absolute value bars nice and tall. Okay, we don't want to write absolute value bars small like that, because that looks like 1 minus 71. And it's hard to tell that we're talking about absolute value. So if you make those absolute, kind of exaggerate them. Make those absolute value bars nice and big so we can tell that that's the absolute value of -7 and not 1 minus 71. So it's really nice to be clear with our notation so we don't cause any errors. Next one, 9 minus 5 times, again, we're going to treat that just like parentheses. If there's a number right next to the absolute value bars, that means we're multiplying. And again, notice that I exaggerated these absolute value bars. Again, I don't want to write them wimpy. I don't want to write them small like this. Whoops. There's not absolute value bars around the 5. Okay, because that looks like 9 minus 5,131. I don't want to do that. I want to make sure that my notation is clear. Well, the absolute value of 3 is 3, so this is 9 minus 5 times 3. So now I can just write that with parentheses, and then I've got 9 minus 15, which is -6. And that is using absolute value, and that is integers and their opposites.